So we have some terminology to get used to with sets, and we have some notation to get used to with sets. So far we noticed that we use capital letters generally to abbreviate a set. So we'll have a set A or a set B, and then we need some kind of description of that set. So let's take set A, actually the universal set, we use the same one I've been working with. So that was, I'm just going to write the elements. That was the counting numbers, no, sorry, the whole numbers less than 10. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then we had set A, which was our odd numbers, 1, 3, 5, 7, and 9. We did a set B, which were our prime numbers, 2, 3, 5, 7. So the curly brackets tell us when the set starts and when the set ends, and we list them in between. Capital letter is the set name. Now, sometimes we'll talk about elements in the set. So if you see something like 2 in this funky shape like that, and then B, this says 2 is an element of set B. I could write something like 2 is an element of set A, but if we look at set A, we can say, whoa, no, wait a minute, 2's not in there. So if something's not an element, we just make the E symbol for element and then put a line through it. So this says 2 is not an element of A. So that's one important symbol. Another symbol we'll come across is the idea of a subset. So if I make a new set, C, and I say C is just the numbers 3 and 5, then I could say C is a subset of B, because the 3 and the 5 in C are also in B. In symbols, that would look like this, C, and then it's a sideways U with a line underneath it, and then B. Now, the line underneath is kind of like a less than or equal to. This says C is less than or equal to B. If I just wrote, let's pick a different color, C with a sideways U, B, that means C is a proper subset. Meaning it's smaller than B. It doesn't have all the elements that B has. So the sideways U on its own is a proper subset. That's kind of like less than. So I could say the number of elements in B, or C, excuse me, is less than the number of elements in set B, right? C has 2 elements in it. 2 is definitely less than the 4, which are in B. And then this one appears like a less than or equal to. So if somebody made up another set that they called D, let's put that up here, and they said set D was 5, 7, 2, and 3, we could say that set D is a subset of B. Now it turns out set B and D are actually equal, right? They have the same exact elements. It would be incorrect to say, so this would be wrong notation down here, that D is a proper subset of B. That is not true because they have the exact same number of elements. So for a proper subset, you can't have all of the elements in the bigger set. There has to be at least one missing. So proper has at least one less element than the other set. So a set can belong to another set. That's okay. So that's a relationship we can have with sets. Other relationships we can have with sets besides the idea of a subset or a proper subset. So we have subset, we have proper subset. Are the idea of a complement, the idea of an intersection, and the idea of a union. So we're going to explore these other three next. So a complement, we'll do that one first. Is everything that is not in the set. And there's different notations you'll see for the complement of a set. Sometimes they'll put a bar over the set. Sometimes they'll put a little apostrophe next to the set. So if you see something like A with an apostrophe, that would be the complement of A. Or sometimes you'll see A with a bar over it. And that would be, again, everything that's not in set A. So if we look back at the sets we had before, where our set A was the odd numbers less than 10, 1, 3, 5, 7, and 9. And my universe, right, the everything set that I needed to consider was 0 through 9. Then the complement of A with a little apostrophe there, would be to just look at the universe and find everything else that's not an A. So we don't want to use 1, but we do want 0, 2, 4, 6, 8. I get them all. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So altogether, the universe should have 10 things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. So again, it's everything else in the universe that's not in the set I started with. So that would be the complement of A. Oh, another notation you'll see sometimes too. All books are a little bit different. Sometimes they'll have an A with a little C up there. So those are different ways. People write down the complement of a set. You could consider it like the opposite of a set. Sometimes it's easy to identify. The opposite of even is odd, but it's not always that straightforward. Sometimes the opposite of a set is just the opposite of a set. It doesn't get a nice name except to be the complement. A set and its complements have no intersection. So let's talk about intersection. It's elements the two sets have in common. The notation for a set intersection is an upside down U. So this is the intersection of A and B. Sometimes it's read A intersect B. Sometimes instead of the word intersect, we use and. So A and B. So it's any element that's in A and in set B. And intersection is that upside down U. Sometimes that's called a cup. Or no, that would be called a cap. Cap symbol. And we took a look at intersections before when we looked at, again, our same universe. We had the prime numbers, the odd numbers, they had an intersection. So I had set A before, which were my odd numbers. I had set B, which were my prime numbers. And 3, 5, and 7 are both even and prime. So A, these were my odd numbers. B were my prime numbers. The other odd numbers were 1 and 9, and the other prime number was 2. Otherwise, outside here, we had 0, 4, 6, and 8. Let's see, did I get them all? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. So there's all the numbers I was talking about before. So in this case, A intersect B would be the list of items they have in common, 3, 5, and 7. So that's the intersection, elements that are in set A and in set B. The next big relationship with sets is union. And set units, union would be the elements that are in one set or the other set or both. And so the union of two sets is written with a regular U without a line coming down. So this is called the cup symbol. And again, we might say A union B. Sometimes we'll see A or B. And this or right here is a little different than the way we use or in our regular language. In regular language, it's what's called an exclusive or. In mathematics, this is what's called an inclusive or. And what I mean by that is my daughter comes home from school, she says she wants a snack. I say, hey, you could have ice cream or you could have cake. Okay? And the implication most people get out of that is, oh, okay, so if I have ice cream, I can't have cake, or if I have cake, I can't have ice cream. So that's the idea of an exclusive or. An inclusive or in mathematics is ice cream or cake means you could have ice cream, you could have cake, or you could have both. So anytime we use or in mathematics, especially with sets, we mean the inclusive or, which is one, the other, or both. So thinking about the same sets we've been messing with, set A here, set B here, the union would be everything in this figure 8 shape. That would be the union. So let's go back to what we had. A were my odd numbers, B were my prime numbers, 3, 5, and 8, oh gosh, 3, 5, and 7 are my numbers that are odd and prime. 1 and 9 are odd but not prime. 2 is prime but not odd. And then we had our 0, 4, 6, and 8 sitting out there. So if I wanted to list the elements that were in A union B, A or B, I list them without double counting. So I would say, I'll even put them in order. 1, 2, 3, 5, 7, and 9. So in the union, right, there's 1, 2, 3, 4, 5, 6 elements. 1, 2, 3, 4, 5, 6 elements. Now, again, keep in mind that A says, hey, I own the elements 3, 5, and 7, and B says the same thing. So when we're counting elements and sets and we're looking at multiple sets at the same time, we got to always be careful of the fact that they could have something in common, like these two sets have. So what I next want to talk about is the relationship between the union and the intersection and the number of elements in both. Back to the intersection for a second. Picture-wise, the intersection, oops, zoom, get out of the way, please. Sorry, I'm having technical difficulties here. Here we go. So that would be this crescent shape. So the crescent shape where two sets meet, that's their intersection. And the two sets put together is that figure 8 shape, and that's the union of two sets. Next, we'll look at intersections, unions, and counting.